Hey guys, in this video I'm going to tell you everything that you need to know to start working with Git. The contents that we are going to cover in this video are: first, I'm going to give you an overview of what Git is and why you should be using it. We'll then see how you can install it and how you can configure it. We'll then see how you can convert a local folder or a repository into a Git repository. I'm then going to talk about the Git workflow, and then we'll add some files and modify some files to see how Git is able to track these changes. Finally, we are going to talk about branches, how you can work on different branches, how you can switch between branches, and how you can merge changes from one branch to another. Hopefully, this video should give you a complete idea of how you can start working with Git. I'll be making a separate video on GitHub and how you can link your local Git repository with the GitHub repository. So if you're interested in that, then please make sure to subscribe to the channel so you don't miss that upload. Hopefully that video will come up by next week. I'll also make sure to leave the timeline to each of the different sections that are covered in this video in the description below. So if you want to skip and watch only a particular section, then you can do that. Okay, now without wasting any more time, let's get started. Before we start working with Git, let's first understand what Git is. Git is a version control system. Now, what exactly is a version control system? It's basically a software that lets you track changes to any files or folders within a Git repository. Now, what exactly is a Git repository? Your any local folder or directory can be converted as a Git repository, and it's very simple to do that. I'm going to show you how to do that in a short while. Let's say you're working on some project and you have written some program in a file and you save that file. Now let's say over time you would be making some changes to that file, so maybe adding new features to the program, or you want to fix some bugs, etc. Now every time you make a change, you would have to save those changes into this file. So you have two options. One, you can save those changes over that file. So what happens is you would kind of lose the older version of that file. And let's say over time you end up making 1,000 different changes, and after 1,000 changes you realize that the last 10 changes were incorrect, and if you wanted to go back to the version of the file which was 10 changes prior to the current file, then it is almost impossible to do that because you do not have any backup of that file, because all the changes you just saved it on the existing file. Now the second way of saving changes to that file would be that every time you're making some changes and trying to save into this file, you make a backup of the older file. So let's say initially you had a file with the file name like file1.txt, and then you make some changes and you save it. So you save it like file2.txt, and then when you make a next change, you save it like file3.txt, so on and so forth. So if you end up making 1,000 different changes over a span of few months, you would end up having 1,000 different files. This basically is redundant and basically 1,000 different copies of the same file, which is actually not required. And we are just talking about one file. Your actual project might be already having hundreds of different files, and for each one change, if you end up making a copy of the whole project, it's basically not required. And in case in future, if you wanted to go back to some previous version, it's very difficult to know which particular version of your backup had the change that you are looking for. Now, this is why we need to use a version control system, and Git is one of the most popular version control system in the world. What Git is going to do is, it's not going to create multiple copies of the same file, but every time you make some changes to that file, it's going to store a history of that file. And in future, if you wanted to go back to some particular history, or let's say 100 versions prior to the current version, you can pretty easily do that. And you can pretty easily do that because you can actually see the difference between an older version of the same file with the current version. And that is why it's so important to use version control systems. Okay, now that you get some idea about what a version control system is and why you should be using one, let's see how we can start working with Git. Okay, so the first thing that we need to do is we need to install Git, and to install Git, just go to your browser and search for Git, and then go into the git-scm.com website. And here, since I am on Mac, it's already showing me the Git version for Mac. If you are on Windows, it would show you the Windows version. Just click on the download, and then for Mac, you have a few different options to install Git. I think for Windows, you just have one option. So it's just like you just click on the download button and then install it, similar to any other software. Even here it's pretty straightforward. So I would recommend to just choose Homebrew. You can choose any other methods of installation as well, but if you already have Homebrew, then it's pretty straightforward. Just run this command and it will install Git on your machine. But if you don't have Homebrew, you can just right click on this and go to the Homebrew website, and here you have this command. So you can just copy this command, go to your terminal and then just paste this command and execute it. It will just install Homebrew. So it's pretty straightforward. Once the Homebrew is installed, you can just go ahead and copy this command. So let me just show you. Let me just copy this command and run it in my terminal, and this will install Git. So I have already installed Git, so it should tell me that the Git version is already up to date. But if you have not installed, then it will install Git. So it's telling that it's already installed. Okay, so this is basically how you can install Git. It's nothing complicated, pretty straightforward. Git is now installed. In order to verify that, you can just go to your terminal and then just type git dash version. This will tell you the version of Git that is currently installed on your machine. The next thing that we need to do is we need to configure Git. So it's nothing complicated. We just need to configure our username, email, and default editor, which we can use in order to edit some files if we want to. So in order to do that, we can just type git config dash global and then say user.name, and you can pass your name. I'll just pass techtfq. Similarly, I can configure my email ID. So I'll say email equal to techtfq@gmail.com. The last thing that I want to configure is my editor. So I can just say git config dash global, and then I say code.editor. And then here you can pass any editor you like as your default editor for Git. I'm going to pass code. Code basically stands for VS Code. Now, for this to work, you need to first go into your VS Code, and here you need to search for your command palette, and here just search for install code. Okay, so this particular command that says install code command in path, just click on that. It's going to install code command in path. So what this will do is, after this, if you ever go to any path from your terminal and then just type code, it will automatically open the VS Code. So to see that, I can just type code and you can see that it's automatically opening VS Code. So this is basically it. We have configured what we wanted to configure for Git. If you want to see a list of different configurations, you can just do git config dash list. It will show you all the different configurations for your user. Okay, so now we have configured Git. The next thing that we need to do is we need to create a Git repository. So let's go into our desktop. So I'm in my desktop, and if I see I have nothing here, so let me create a folder here. So let me say mkdir projects, and let me enter into projects, and here let me create another folder, and I'm going to call it like digital clock, because this is a project that we are going to create during this video. So I create this folder and I enter into this folder. Okay, so one thing to remember is that, as you may know, whenever you're working on project, all the files about a particular project would be within a particular folder, right? So if you have multiple projects, then you would have multiple folders holding each folder holding the files of a particular project. Same way for Git, you need to create one Git repository for each project. Okay, so now I am inside my folder digital clock, and I want to make this particular folder as my Git repository. So if I just type ls, there is nothing here, and if I want to see the hidden files, I can just say ls-a, and you can see there is no hidden files as well. Now in order to convert this particular folder as a Git repository, I can just run a command called as git init, and that's all. So this will initialize Git in this particular folder. So what actually happening is, it's not actually going to create any files or folders, but there is one hidden folder that it's creating. So in order to see that, I can just say ls-a, and you can see that there is a .git folder. It's a hidden folder that has been created. Now this is required for Git in order to track any changes in this folder. Okay, so now we have converted our local folder into a Git repository. Now we have our Git repository. Now let's add some files and make some changes to see how Git will be tracking these changes. Okay, so let me just clear this. Let me just zoom this. Before we add any files or make any changes, let's first check the status of this repository. We can do that by just saying git status. You can see that there is nothing to commit, meaning that this basically is an empty folder. We have not done anything in this folder. So basically there is nothing for Git to track. One important thing to note here is when you type git status, it's going to tell you the branch on which you are. Now it's telling me that I'm on branch master. By default, Git will always have master as its branch. What exactly is a branch? A branch can be said like it's an independent snapshot of your repository, and each repository can have multiple branches. So let's say you have a branch master. So any changes or any commits that I do on this branch can only be seen from this branch. It will only impact this particular branch. So if I create another branch, let's say child, and make some changes there, add some files and do some changes to a file, then those changes can only be viewed from that particular branch. So it's something like an independent snapshot of your repository. So, and your repository can have multiple branches. Okay. So I'm going to tell you how to work on branches in a short while, but for now, this is just an overview. So we have seen the Git status, and there is nothing much happening on this repository as of now. So let's go ahead and create some files. So I'm going to create a file by using the detached command. I'm going to say file1.txt, and I'll create another file. So let's say file2.txt. If I click ls, it's going to show me the two files. And now if I do git status, you can see that I'm on branch master, and then there is these two files under the untracked files category. So basically what Git is telling is there is something that has happened in this folder. There are two files that have been added into this folder, but these files are untracked, meaning that Git is currently not tracking them. And the reason why Git is not tracking them is these files are not yet added into the staging area. This is where I'm going to give you an overview of the Git workflow. So whenever we have a Git repository, what happens is there are internally three layers that Git refers to. The first is the working directory, which is basically your local folder that you have created. And then there is something called as a staging area. So in order to commit something, that is when I say commit, it's basically saving the changes or files to the Git repository. In order to commit something to your Git repository, first it needs to go through the staging area. That is, from our working directory, we need to add the changes to the staging area. And once the changes are there in the staging area, from there, we can commit it to the Git repository. Once the changes are committed, it is saved permanently. Okay. Whereas once it is in staging area, you still have the option of either removing it from the staging area or then committing it permanently to the Git repository. Okay. So this basically the workflow. Now, if I go back to my terminal, so I have these two files, and these two files are untracked. So these are just added in my working directory. They are still not there in my staging area. Now, if you want to see what are the files in our staging area, we can just run a command like git ls-files. Okay, currently you can see that there is no files. Now, in order to add these files in our staging area, we can just use the command like git add and then the file name. So I'll say file1.txt, and I can pass different files here. So file2.txt. Now these files are added. So now if I check the Git status, you can see that from red, now these files are shown in green, and you can see that it's telling changes to be committed, meaning that these are now present in the staging area. So as I told you, in order to commit any changes to Git repository, there are two stages. First, we need to add it to the staging area, and from there we can commit it to the Git repository. Now, if I look at my staging area files, so I can just say git ls-files. Here you can see that now there are two files added into my staging area. Once these changes are present in staging area, from here I can commit it. But before I can commit it, you realize that you actually didn't want to add file2.txt to staging area. You don't want to commit it. So you can actually remove it from staging area, and actually Git is already recommending the command in order to unstage it. So you can just type, let's say git rm -- cached and then the file name. So I'll say file2.txt. I don't want to add it. So if I just run that, and now if I just check git status, you can see that it's telling there is one file that is ready to be committed, meaning that this is present in my staging area, that is file1.txt, and then there is another file, file2.txt, which is untracked, meaning that this is only there in my current working directory, but it is not present in my staging area. Okay, so this is basically the flow. Now for now, let's say I want to add this file2 as well. I want to commit this as well. So I'll just go ahead and add it. So either I can mention file2.txt here, or instead of mentioning the file name, I can just mention a dot. Now what dot will do is everything that is there in your working directory or your local folder will just be added into the staging area. Okay, so now if I check my Git status, you can see that these two files are now added in my staging area and we can commit it. So in order to commit it, I can just say git commit -m, that is -m, and then you just pass a commit message. This commit message is very important. You should always make sure to provide meaningful commit message which can indicate the changes that were done. So here I'm just going to say added 2 new dummy files. So my files are now committed. Now if I just clear this and if I just say git status, you can see that there is nothing. Now the git status, it's telling that the working tree is clean, so there is nothing to be committed. So this is basically how we have created 2 files and we have added that files into the staging area first, and then from staging area we have committed it into Git repository. Now you might ask, why do we need to add files to staging area before we can commit it? The reason is that before you commit something permanently into the repository, you just want to review it once and make sure that all the changes are correct and as per what you wanted. So it's something like a caution. You first add it into a staging area and then you review your code changes, and once you think everything is fine, only then commit it, because once you commit it, it is permanently saved. Now there is also a way that we can skip this process of staging area and we can directly commit the changes to the Git repository, but it is not recommended and I'm not going to cover it in this video. So we have seen how we have created 2 files and added that files to staging area and then committed it to Git repository. Now let's say I want to create another file. Okay, so I'll create another file. Let's call this like digital clock.py. So this is actually going to be my real file where I'm actually going to write a simple Python program which is going to display a digital clock in my screen. But I'm going to work on this project step by step. So I'm not going to do everything at once. I'm going to do step by step and do several commits. So you just get a flow of how we actually use Git to record different changes. So the first thing that we need to do is let's open this file and write a simple code. So in order to open this file, I'm going to open it in my default editor, that is VS Code. So I just say code and then I pass the file name, that is digitalclock.py. So let me open that folder just so that you can see it. And so this is my folder and this is my file, and this is where I'm going to write my program. So I'm just going to write a simple program. Okay, so I have written a simple program. It's just going to display some screen. I'm going to save it and let's see what is the output from that program. So I can just say Python 3 and the program name. You can see it's a simple screen. Now this is fine. So let me go ahead and commit this file. Okay, so I can just say git add dash and then git commit -m and then a commit message. So I'm going to say like added a new digital clock program. Okay, so I've done the commit, and if I check the status, there's nothing else on this branch. So if I wanted to check the history of all the different commits that I have done on this particular repository, I can just type the command like git log and it will show up all the different commits. So this was the first commit that we did. If you remember, this is a message that we gave, added 2 new dummy files, and you can see here that this is basically the commit hash ID. It's something like a unique identifier for each commit, and then you have the username and the email that we configured initially, and also the time of this particular change. Okay, so this is basically the history of the first commit, and then I have another commit here which I just did where I added a new digital clock program. Okay, and here you can see that I have something like head. Head is something like a pointer which will either point to a branch or it can point to a commit. So I can change this head to point to either a particular commit, and we are going to look at that in a short while. For now, just imagine head to be something like a pointer, so it's pointing to the current commit or the current branch what we are working on. Okay, so this is my log. I can also print this log in a single line, so I can just say git log dash one line. Just it will display the whole log message in a single line. Okay, so now I have created a program here like digital clock.py, which is basically showing a sample screen. Now I want to modify that to maybe make it more colorful, and then hopefully add a digital clock over there. Okay, so let's clear this, and now let me open that file and make some more changes. So I'll open this file, and now what I'm going to do is let me add some background and add some label with some welcome message or something. Okay, so I have written this program. Now let's go to my terminal and try to run that. So I say Python 3 and that program, and you can see now this screen has become slightly colorful and it's displaying a welcome message. So let me close this and let me now commit these changes. So I can just say git add dot, and then I say git commit -m, and then a message. So I say added a welcome message. Okay, so now let me clear this and just check my log. You can see that I have 3 different commits now, all in my master branch. Now if I execute this program again, so you can see it's displaying welcome, but somehow I didn't like it and I want to remove this welcome message. So what I'm going to do is, again, I'm going to make some code changes. So I can say that code and that program, and now here I'm just going to remove this welcome message. Okay, so I'll remove that, I'll save it, I'll go back here, I'll run this. It's a blank blue screen. This is fine, and now I want to commit it. So I can just say git add dot, and then I say git commit -m, and then I pass a message saying that removed welcome message. Okay, so if I clear this and if I check my log, you can see that I now have 4 different commit history. So this was my first commit, my second commit, my third commit when I added a welcome message, and my fourth commit when I removed my welcome message. So all this is fine, and I have only worked on my master branch. Now what I want to do is I want to add a clock, a digital clock, into that screen. But since it's a feature that I'm going to add to this screen, I don't want to make all these changes directly in the master branch, because master branch is generally the branch which gets committed into production, and that is what is basically getting released. So we generally do not want to do some experiments or try out new features using the master branch. So whenever we want to try out new features or do some experiments, we generally do it in a different branch. So what we are going to do now is we are going to create a different branch which will basically be a copy of master, and then on that new branch I'm going to actually make the digital clock, and then if I like it, only then I will merge it to the master branch. Okay, now to do that I'm going to create a new branch. So but before that, let me just maximize this and go back here. So this looks more cleaner, and here in order to check all the branches that we have in our repository, we can just type git space branch. Here it's telling that there's only one branch master, and this star symbol basically indicates that this is the branch you're on. Now in order to create a new branch, I can just type git branch and some new branch name. I'm going to call this like clock. Okay, so now if I type git branch, you can see that now I have 2 different branches, and the star is still pointing to master, meaning that my current instance is still pointing to the master branch. I want to change it to the clock branch, but before that, let's just look at the log messages. So let's see in which branch I am on. So I can just do that by saying git status, and you can see that I'm on branch master. Here let me check the log, git log, and I just want in one line, so I'll say this, and you can see that in master I have 4 different commits, and the last commit, that is which is the head, is pointing to my master, and clock, the different branch that I created, is also in the same commit. Okay, so meaning that master and clock are currently having the same code, their versions are the same. Now let's switch back to clock. How you can switch from one branch to another is by using the command called as switch. So I can just say git switch clock, and now you can see that it's telling switch to branch clock. And let me run the log message here, and now you can see that the git log in my branch clock, here the head is pointing to branch clock, but both these branches, master and clock, are pointing to the same commit, meaning that all the files and codes are exactly the same across these two branches. But now we are going to do some additional changes in the clock branch. Let's clear this and do some changes in our code to actually print the digital clock. So I can just say clock code digital clock, and here now I'm going to add a function to display the digital clock. Okay, so I have added my function which should hopefully print the digital clock on my screen. If I go back and run that program, I can just say Python 3 and the function name. So you can see that inside my blank screen now a digital clock is being printed. So let me close this and let me now commit this. Okay, so I'll just say git add dot, and then I say git commit, and I pass a message saying that added digital clock to the screen. Okay, so now I have done the commit. Let me clear this and let me now look at the log. So I say git log dash one line, and you can see that now from this log you can see that my master is in this particular commit, but my clock, since I made a new change and I added the digital clock, it's having an additional commit, that is this one. Okay, so now you can see that my master branch and my clock branch are in two different versions. Okay, now to verify that, what we can do is, now we are in the clock branch, right? So I can just confirm that by saying git status. Yeah, so we are on clock. If I run this program, that is this program, you can see that the screen is printing the digital clock. But now if I switch back to the master branch, so let's say git switch to master, and then if I run that program, you can see that there is no digital clock. It's just a blank screen, and that is because I am on the branch master. So meaning that my master branch is having this code. You can see here I have this particular code where I do not have the clock function. But if I switch back to clock, and if I go back to VS Code, you can now see that it's having this particular function. So it's the same folder, same file, but two different versions of the file. The reason for that is because of two different branches. My master branch has a different version of the code and my clock branch has a different version of the code. And this is very useful. So you can maintain your master project or master software or the main software as it is. When you are trying to experiment or create new features, you can just create those features in a separate branch, and then if you're satisfied, only then you can merge those changes into the master branch. Now let's try to do that. So let me clear this and let's switch back to master. So let's say switch to master, and I am switched to master. Now I want to merge all the changes that I did in my clock branch into my master branch. Okay, so but before that, let's just check the log. Here I'll just say one line, and you can see that I only have 4 commits, and the last commit is master where I said removed welcome message. So basically the addition of the clock is not present in master. So I'm just going to merge the clock branch, everything from clock branch into my master branch. So how I can do that is I can just use the command like git merge and the branch name clock. So you need to be on the master branch, and then you need to type this command saying that git merge clock. So it will merge all the code or all the files or all the changes from this particular branch into the master branch. Okay, so now if I execute, you can see that it's done. It's telling that it's inserted 7+ lines and it's modified 1 file. Okay, so now to confirm that, what we are going to do is we are in our master branch. So let me run that Python program. And you can see that now my master branch is also having this digital clock. Okay, so if I go back to my VS Code, you can see that this is my master branch and the clock function has been added just by a merge. So let's just look at the logs between these two branches. So I am on master branch, And let me just check the log, git log dash dash one line, and this is my master branch. And now let's switch back to the clock branch, git switch clock, and here if I check the log, okay, so you can see that now everything is same. Only thing is, in my clock branch, head is pointing to the clock branch, and in master branch, head is pointing to the master branch, but the commits are all the same. You can also verify the commit IDs, the hash IDs, they're also exactly the same. So this is basically how we have merged changes from a different branch into a master branch. Now, let's say my manager comes to me and tells me that he didn't want the digital clock to be committed to the master branch as of now. He wants the master branch to still point to a blank screen. Basically, now we need to change the repository to point from this commit to actually this commit. And this is the advantage of Git. If you wanted to go back in time and change all the code and changes of your repository as per some old history, you can pretty easily do that. So if I wanted to switch back my master from this particular commit to this particular commit, I can just copy this commit, that is this commit hash ID, and here I can just say git reset dash dash hard and then enter the commit. So now you can see that head is now at this. Now if I just check my log message here, you can see that previously my master branch was having 1, 2, 3, 5 commits, but now you can see that my master branch is only having 2 commits. Okay, because I changed the master from this particular version to some prior version, and that is the advantage of using a version control system. So now let's say you have a requirement where your manager wants you to now display a red screen with a welcome message. What you can just do is, if you go to master, you now see that it's a blank screen. There is basically no welcome message, nothing. But if I switch back to my clock branch, and if I just check the log, let me just clear this, log dash dash one line, you can see that I have a lot of versions of my code. The last version is the digital clock. I don't want that, but I have prior to that I have a version here where I said added a welcome message. Okay, but this was not in red color, it was in some other color screen, right? So the requirement now is that we need to add a red screen with a welcome message. So instead of doing everything from scratch or creating a new branch and then removing all these changes, what I can do is I can use the checkout command to point at exactly this commit, and then from here I can take over the code and do whatever changes I want. So how I can do that is I can just say Git Checkout and then I pass the commit ID. So I want this one, so I'll just say this, and now you can see that it's telling switching to this commit and you are now in detached head. Now this detached head is basically the reason for that is if I just check my log, let me just show you the log just so that it becomes very clear. Git log dash dash one line, and you can see here that my head is pointing to a commit. Previously we were seeing that the head was pointing to a branch. So the head can either point to a branch or it can point to a commit. If the head is pointing to a commit, then it is called as it's in the detached head state. Okay, now in the detached head state, it's basically not a branch. It's not in your master branch, it's not in your clock branch. It's something like its own temporary branch, and from here you can make code changes and then commit it and then maybe create your own branch for those changes. Okay, so let's see how to do that. So let me just clear this, and you can see that I am here dash dash one line, and I have this some welcome message. Let's see how my Python program looks now. So I say Python 3 and run this. It's displaying welcome. This is fine, but I want a red screen. So what I'm going to do is I'm going to do some modifications here. So I say code and I run this, open this program, and I have configured the background to be steel blue. Let me make it red, and even here let me make it red. I'll save this, and now let me run my program, and you can see now it's displaying a red screen with the welcome message, and this is exactly what we wanted. Now this is not part of any branch, it's not part of the clock branch, it's not part of the master branch, it's just a detached head state. So what we need to do is we need to commit this. So let's first commit it. So let's say git add dot, and then I say git commit -cm, and then pass a message, change to red screen. Okay, so if I clear this and if I check the log, and now you can see that I started this, previously my head was pointing to this commit because this is where I did the checkout, but now since I made a new change and I committed it, I'm getting a new version of this code. Okay, but this is not stored to any branch. So what we are going to do is now we are going to save these changes into a new branch. How we can do that is I can just say git switch -c and then pass a new branch name. So I'm going to call this like red screen. Okay, so you can see that switch to a new branch, red screen. So now if I do git branch, you can see that I have 3 branches and there's a new branch that is created, red screen. Let's clear this. Let's just see how our 3 different branches are working together. Okay, so let's say git branch. I have all these 3 branches, and now let's say I do git status. I'm on my red screen branch. From here, let's say I want to run my Python program. So I say Python 3 digital. You can see it's displaying the red screen with the welcome message. Now if I go back to my master branch, so I say git switch master, and from here if I run my Python program, you can see that the master is just having some blank screen, nothing here. And now if I switch to my clock branch, so if I click to clock, and here if I run my Python program, you can see that it's having a digital clock. So basically we are working on the same repository, but it's having 3 different branches, and each branch is having its own version of the code. And if you want, we can merge between these versions of the code into a single branch. So this is basically how we work with a version control system, in this case Git. Hopefully it was all clear and it was not too confusing. If you like this video, please make sure to like this video and also add a comment with your feedback. And also if you have any questions, do ask it in the comment section below. And do subscribe to the channel, and I'll be posting a video on GitHub in the next week. So make sure you're subscribed and stay tuned for more interesting and useful videos. Thank you and have a good one. Bye.